In the final activity on the DVD called Using the X in Box, Brad summarizes all the tools we've covered so far and also integrates the box and the X methods. Brad's creative use of the words attic, ceiling, and basement to stand for the three coefficients of a trinomial allows students easy ways to remember how to factor any trinomial they run into.
We've covered a lot of territory in this series as we've transitioned students from very basic levels up into higher levels of factoring polynomials. And what we've done is introduce certain skills that incrementally build one upon the other. Now what we're going to do is weave all of those skills into one procedure that will allow them to tackle any problem they ever face in factoring a polynomial. As they work with these, this A term can get to be pretty cumbersome. So what we want to do is have a strategy where they can solve these without a lot of guesswork. And in fact, there is one. We simply take all the tools we've covered so far and weave them together. Instead of using the X or the box, we're going to use the X and the box. So we draw the X that has helped us before, and we draw a box. And there's really only one new thing that we have to learn now. In the past, the A term was always generated in the upper left-hand corner of the box, and the C term was derived from the lower right-hand corner. We also know that the B term resided in the basement of the X. We put the C term up in the ceiling. However, another thing that's up in a house is the attic. So if we remember that B stands for basement, and A and C stand for attic and ceiling, we put the product of the A and C terms on the top of the X. Positive 4 times positive 3 is 12. Now, earlier we didn't need to do that because our A term was 1, and 1 times C is just C. That's why we didn't use the attic term previously. But remind students, B is still for basement, C is for ceiling, and A is for attic. Now we solve this X puzzle. I'm multiplying two numbers to get a 12, but they add to negative 13. Well, it turns out the only solution to that is negative 12 times negative 1. We place those two terms into the remaining cells of the box. This will be a negative 12x, this will be a negative 1x. The last thing that we do is we look this over and see what they have in common. If you look at the first column, both of those terms have an x in common. Other than that, these coefficients have no common factors other than 1. So we just leave it there, or we could put a 1 there if we desired. Going into the second column, they don't both have an x, but I do notice that 3 goes into both of those. It goes into 12, and it goes into 3. So that's a 3. To determine if it's a positive or negative 3, I take the lead sign of the first term, x minus 3. That is actually one of our binomials, x minus 3. And really, once you know one of those, you could then work backwards as we did in a previous activity and find the remaining terms. But you don't have to. Again, I can look at these two terms in the top row and say, what do they share in common, or what are their common factors? Well, they both have an x, so I place an x out in front. And 4 and 12 are both divisible by 4. Since the lead term is positive, that remains positive. In the bottom row, they don't both have an x. The only coefficient that will go into these, the only factor that will go into those coefficients is 1. And since the lead coefficient is negative, that is also negative. And there is my second binomial. Now if I test this, I do get 4x squared on my first times my first term. And I get positive 3 for my last times my last. Looking at my outer terms, I get a negative 1x and a negative 12x, there they are, which combine to make negative 13x. So I've solved this now with no guesswork whatsoever. Let's look now where these numbers get even worse to deal with to see that this method always works and doesn't require any guesswork. For our final example, we're going to explore a polynomial where the A term and the C term are factor rich, meaning that there's a lot of ways we could make that 6. And even more ways to make a negative 6, where one term is positive and one is negative. And I don't want to guess my way through this, and that's why I want to use this method that combines all the tools we need, both the X and the box, in one efficient method. Now there seems to be a lot of steps to this, but because of the way we've built these concepts one upon the other through the course of this instruction, there's not a lot of new things the student needs to do. The student already knows how to make an X to solve these types of problems. The student also knows how to make a box to solve these types of problems. And from past experience, they know that the A term is generated by the upper left-hand cell of the box. The C term, consequently, comes from the lower right-hand cell of the box, and the B term resides in the basement of the X. The only thing that's really new to the student now is the fact that the top of the X doesn't just contain the C term, it's the A times of the C term. Both the attic and the ceiling are up there. So 6 times negative 6 gives me a term of negative 36 in the top of the X. That's the only thing we've added to this instruction compared to the previous layers. Now let's look at this puzzle. I need to multiply two numbers to get a negative 36, and they will sum to a negative 5. Well, clearly, if I multiply two numbers and get a negative product, one of them must have been positive and one of them negative. Now, if your students have been solving these kinds of problems throughout the year to practice integers, they should be pretty good at them by now. And they'll eventually realize that a positive 4 and a negative 9 will multiply to negative 36 and add up to negative 5. I then move those terms over to my remaining cells of the box. And it doesn't matter whether you put the negative 9x here or down here. Either one will work fine. But I put negative 9x there and positive 4x here. Then I look for common factors. And we've been doing this ever since we did the worksheet called Working Backwards. What binomials generated those terms? Well, if I look at this top row, I notice that both of those have x's in them. So I pull an x out as a factor. I notice that 6 and 9 are both divisible by 3. Since my lead term is positive, so is that 3. On the bottom, I don't have common x's, but I do see that 2 will go into 4 and 2 will go into 6. So I pull out a 2. Since my lead term is positive, so is that 2. I now know one of my binomials. And once you know one, the other one's not hard to figure out. But we'll go ahead and look at our column anyway. Our left-hand column has x's top and bottom. I also have a 6 and a 4, both of which are divisible by 2. Positive 2, since that's a positive 6. My right-hand column has an x here, but no x's here, so I can't factor an x out of those terms. However, if I have a 9 and a 6, ignoring the signs for now, both of which are divisible by 3. Since that lead term is negative, so is that. I now have 2x minus 3 and 3x plus 2. Let's FOIL this to verify that it is right, just to check our work. Here I see 6x squared, which I like. Last times last gives me negative 6, which I like. And my outer terms gives me 4x. My inner terms, negative 9x, which I see here. Those two combine to negative 5x. And I've solved this fairly complicated polynomial without any guesswork whatsoever by simply building each concept upon the one previously learned until this is very easy for us.
This is just one part of a 72-minute DVD and accompanying handout that will help your students learn more about multiplying and factoring polynomials. For more information, visit www.tttpress.com.